Good evening, Mr. Vincent Jiang, Mr. Deng Geng Chiu. You are all visionary leaders. Without your effort, we don't have this Hong Kong Life Science Society and all the investment in life sciences in the last 10 years. I'm much more science than entrepreneur. And I just want to share with you my personal journey, how I go into the field, how I make discovery. So this is when, many years ago, before you are born, in 1981, when I graduated from the University of Hong Kong. This is my parents before Lok Yew Ho. And what happens in my students' days matters a lot to what I do in terms of research. So I was lucky to get a distinction viva during my graduation as a medical student. And this is one of the patients that I saw during the distinction viva at Queen Mary Hospital. So Professor David Todd asked me to examine this patient and what is the diagnosis. And I always remember it. And if you have good eyes, you can see the patient's abdomen have these spots, what we call rose spots. And the patient's abdomen is distended with some tenderness over the right low quadrant. And of course, there are hints adjacent. In those days, when a patient has infectious diseases, usually there is a bucket of disinfectant adjacent for cleaning your hands immediately after examining the patient. In those days, we don't have any alcohol hand rub. And my diagnosis, of course, is the patient is suffering from typhoid fever, which is now very rare. We only around 20, 30 cases per year in Hong Kong. But in those days, in the ward, typhoid fever is just common. Now, we do not know whether I have the gift in infectious disease or my interest in infectious disease. I don't know. No, but one thing that is for sure, in those days, my teachers always quote Dr. William Stewart, who is the United States Surgeon General, which is basically equivalent to the Director of Health in Hong Kong, Dr. Ronald Lam, for example. And what he said in 1967 is that it's time to close the books on infectious diseases, declare the war against pestilence won, and shift national resources to chronic problems like cancer and heart diseases. Now, that is what our teachers told us in those days. And that, well, we have antibiotics, we have good sanitation system, and we have vaccines. So why don't we forget about infectious disease? That's time for cancer and heart diseases. And I just want to tell all the young people here, the authorities are often wrong. So do not listen to what they say 100%. They are wrong in more than 50% of the time. Now, of course, you know that I finally go into infectious diseases because I think that in those days, Professor David Todd was teaching infectious disease. And I asked him, why are you teaching infectious disease? You are the chair of hematology. You are the world expert on G6PD deficiency and also thalassemia. And he told me, because none of my colleagues are interested in infectious disease anymore. But I find infectious disease very important because it can cause outbreaks. Affect a lot of people. And then a lot of people would die because of outbreaks. So since I'm the head of department, I have to take up the responsibility to teach this. Now, all what Professor David Todd told me is deeply ingrained in my mind. I always remember what he said in this way. Although he also said that you guys should do cancer and heart diseases. Now, so I finally graduated and then become a surgeon and also a physician. I have 5 years of training in surgery and 2 years in internal medicine before I joined microbiology. And that is my first paper published in Lancet in 1994. At that time, suddenly there is a fungal infection called Penicillium menafia. Now the name is changed to Tauromyces menafia, mainly affecting the AIDS patients, but also in patients on immunosuppressant like steroids and other immunosuppressants for autoimmune diseases. And so I say something is wrong. And at that time, it's not easy to diagnose this disease because you have to grow the fungus. It took around 14 days before it could be cultured from blood, bone marrow, or the lymph node biopsy. So rather invasive. If you can't, you take your blood, it doesn't grow. You have to take out the lymph node using surgical biopsy or to do the bone marrow biopsy before you can culture it. Now I do something very simple. I do the first serological test. I devise the first serological test to diagnose this infection. And what I did is, I germinate the conidia, the spores of Penicillium larvae. So you can see here that you can see the spores here. Yes, the spores. And then I germinate it in serum, in plasma, in rapid plasma, and then coat it on a slice, and then react with the patient's serum. And if it reacts, it produces an apple green fluorescence. That is a very simple test. And nobody had thought about it at that time. I am the one that thought about it and then put it into action. And you know that I was quite silly in those days. I don't know that Lancet is the best medical journal in the world. I just see in the library there is a journal called Lancet. Hey, so I just sent it to them and see what happened. And it was accepted. And I don't know that being accepted by Lancet is a great honor. I know nothing about it. And then somebody in pathology department, I forgot the immunologist, Lawton, Dr. John Lawton, tell everybody, hey, this guy in microbiology, K.Y. Yuen, he published a paper in Lancet. And you know that at that time, I must say that in the university, very few, if any, people publish in Lancet. So that is a big thing. And suddenly everybody know about K.Y. Yuen, which I don't know why it should be of such honor, because I just use something very simple. Something to me is very automatic. Something is almost intuitive, and then get a diagnostic test without taking invasive biopsy from patients. Now, so that is the first start, and I'm quite encouraged. And I find the thing about, I was an HA staff, a hospital authority staff. I'm not a Hong Kong U staff. And then the professor of microbiology said, KY, why don't you join Hong Kong U microbiology? And that is the start of my research career. I was graduated in 1981, but I only joined the university after 1993, 94. And you know that I'm a very late starter in research. All my colleagues, my classmates in Hong Kong, who joined Hong Kong U very early on, already become readers and associate professor. I'm just an assistant professor when I joined in 1994. Now then, of course, the university sent me over to learn something somewhere. At that time, I go to Fred Hutchinson's Cancer Research Center in Seattle under the mentorship of Professor Joel Myers and also Adam Gibel. Now, what I learned is at that time, that is cutting edge technology, PCR and sequencing. That's all that I know. In fact, my colleagues, in those days, everybody is learning these two techniques. Now, technology is one thing. Technology helps you to answer a question. Unless you have an important question to ask, acquiring such technology is not going to bring you anywhere. So you must be able to answer a question that is completely innovative. All right? And that is the most important. And then the technology helps you. So at that time, you know that I'm doing bone marrow transplant infection. And one of the important viruses is cytomegalovirus and human herpes virus type 6, mainly in bone marrow transplant recipients, but also in AIDS patients. Now, so I bring the technology back and then start to monitor the CMV, the cytomegalovirus viral load in the marrow transplant recipients. And once they start to rise, the amount of DNA goes up, we immediately start the patient on what we call ganciclovir preemptive therapy, which is an antiviral for the cytomegalovirus. And that was very successful. The patients all do well with this PCR technology, trying to assess the viral load of patients using, in those days, qualitative PCR. But if you have 2 consecutive positive PCR, we start you on ganciclovir. In that time, we don't have light cycler. We are still running a gel, using air-cooled cycler, which is a very, all are now in museum. Nobody uses them anymore. But that is how we do it in those days. Now then, finally, Professor Ng, who is my predecessor, said that I'm going to retire KY, and now I rapidly promote you to reader and then later chair professor. And when I was promoted and start to lead the department, he said that you should set a research direction for the department. And that is difficult. And then I think about it and only ask one question. What can shut down Hong Kong? That's all. And then I reviewed one of the historical document about the population of Hong Kong. You can see that as Hong Kong progresses from 1841 to 2003, the number of people is actually increasing, all right? Now, actually, this is added afterwards. When I do this, is in around 1998, 5 to 8. Now, I find that the only time when the population decreases, one, in 1941, the World War II. People run away, go back to mainland China or go to Southeast Asia to escape the Japanese invasion. Another time in 1894, when half of the population is lost because of plague, Yersinia pestis, 鼠疫. So you can see that we have a lot of problems that can shut down Hong Kong and the world. But the two, historically for Hong Kong, is war, which is political changes. The other is infectious disease outbreaks due to emerging or re-emerging infection. Now we have a lot of problems like aging population, global warming, water, food, energy shortage, lack of land and space, mass poisoning or radiation pollution due to nuclear plant explosion, etc. But what can a microbiologist do? Right? The only thing that I can do is to tackle infectious disease outbreaks. So I say to Professor Ng, I think the department should go in the direction of emerging infectious disease outbreak. Because we have so few people, we have no money. Thanks to Vincent and Karen for your great support from time to time. But overall, we are very poor people because the microbiologist is the lowest animal in the animal kingdom. Now, so as time goes by, this is 1997, the handover of Hong Kong back to mainland China. And then the Chinese Medical Journal invited Professor Menhan to write a paper in commemoration of the return of Hong Kong to mainland China. And Professor Ng says, KY, can you supervise a postdoc to write this review? And he asked me, what title do you want to write? I say, well, of course, emerging infections. Now, so the title that I give is Emerging Pathogens, the Hong Kong Experience, and I supervise Dr. Siu Hong, my postdoc fellow, to write this paper for the department. And you can see here, the first reference that I quote is from Professor Joshua Lederberg from Rockefeller University. And interestingly, after I write this, I forgot about this, and I forgot about Joshua Lederberg. And then something happens afterwards. Soon, almost at the same time, is in 1998 that we have this major outbreak of influenza A H5N1 Kam Lau Gam. And I again write a paper to Lancet and accepted very soon. Within 3 weeks, it accepted about the clinical features and rapid viral diagnosis of influenza H5N1. Again, using the technology RT-PCR that I learned from Fred Hutchinson's Cancer Research Center. Now, so the outbreak was stopped by the killing all 1.4 million chickens and other poultry in Hong Kong. And that is my actually first experience with a major emerging infectious disease outbreak. Now, then suddenly, just 2 to 3 years later, I received an email from Professor Joshua Lederberg. And he asked me, he gave me an email. I read your papers in Lancet, one on H5N1, and another one actually is on cell wall deficient bacteremia. That is the last bacteria paper that I wrote, in fact, again accepted by Lancet. I saw it, and I'm all interested to come to Hong Kong to see you. The Nobel laureates want to see me. I honestly answer him, thanks, Professor Lederberg. I know that you are Nobel Prize laureate in actually cell wall deficient bacteria. And I would like to discuss science with you, but I have no money to fly you to Hong Kong. That is true. because you have to give people business class tickets. And he answered me, he said that no need. I would pay myself for the business air ticket, but can you book an accommodation for me and my wife? I say, of course, yes. I book, in Hong Kong University, there's a Robert Black College, very cheap. And just a few nights. And then he come to Hong Kong and discuss with me science. I pick him up at the airport around 8 o'clock, and we discuss science until 3 o'clock in the morning. Very interesting. We talk about everything about infections. And he spoke at the Raisin Huang Lecture Theatre in 2001, and when he came in 2001, on emerging infectious diseases and bioterrorism. Now, after the talk, he encouraged me, don't leave emerging infection. Don't go for HIV or bacterial genomics, because Hong Kong U does not have the strategic advantage over other people. Now, remember at that time, genomics is very hot, all right, at that juncture, 2000 year 2000. And HIV is, of course, very hot. David Ho, my very great friend, again, is doing HIV. And obviously, we don't have their track record. We don't have the amount of collaboration. We have basically very little. And you jump into an area where you are not familiar, it's not going to bring you anywhere. But I learned already, my 1997, that respiratory RNA virus is very important. They spread easily. I'm still wearing a mask because the hospital say every hospital staff should wear a mask in order not to produce an outbreak in the hospital. So you know that respiratory viruses, especially RNA viruses, which mutate very rapidly, would always pose a threat to mankind, Now, so just after another 2 years after the visit of Joshua Lederberg, we now have the coronavirus. And this is SARS-CoV-1. And this is 6 years after H5N1, all right, by that time. And that is very important because we are the first group in the world that find SARS-CoV-1 as the cause of SARS. So you can see that here, I have a lot of collaboration with different people in Princess Margaret, in Government Virus Unit, in Pamela UD Hospital, in Kwong Wah. In fact, Kwong Wah Hospital is the first hospital to consult me. I saw the first SARS patients in Hong Kong, and then pathology in QE, etc. Now, why can we have such amount of collaboration all over Hong Kong? Because by that time, I have started a course on called what we call a postgraduate diploma course in infectious disease. And many doctors all over Hong Kong, whether microbiologists or internal physicians, come to attend my course at Hong Kong U. So I have a lot of connections. When I ask them for help in getting specimens, getting clinical data, they're very willing to give it to me. Just like what Vincent is doing now. Connected all over the place, with all the young people, with all the entrepreneurs, with legislative council, etc. And that is important one day, because one day when you ask people to help, they are very willing to give you because you have helped them. So that is after many years of preparations. Since 1994, when I first had my first Lancet paper, we have a rapid research response for the year of SARS in 2003. Remember in CDC US, they have hundreds of people, literally 300 to 400 people working on SARS-CoV-1. I only have a total of around 12 people working on SARS-CoV-1, and we win out. And that is how we do things. We saw the first Hong Kong case. We isolated SARS coronavirus. We developed rapid diagnostic tests. We established association between the virus and the disease. And my colleagues, Guan Yi and also Jiang Bojian, they go in the mainland and found the amplification holes in the civet, right? And then kill all the civets in the market, and then the outbreak stops. Now, science is about finding the inner layer, the ultimate layer. What is the ultimate cause of a problem? So I advise all the scientists here, young scientists here, do not stop after you solve a problem. You think that you solve a problem. You always try to establish a research pipeline and ask the final question. Where is the natural reservoir of SARS-CoV-1? Now, why I ask this question is because of two reasons. First, why I say it's an intermediate amplification host is when we sequence the spike protein, we sequence the genome of SARS-CoV-1, you know the spike is the outermost protein projections outside, encoded by a gene called S, right? So we sequenced this S and found that actually this is the Shenzhen CVID isolates, and this is later in Guangzhou, because we know that there is first outbreaks in early 2003, and then another outbreak in late 2003 after they resumed the selling of CVID on the market, right? So initially they kill everything, but then they say that, hey, nothing happened afterwards. So after July, I mean, all the CVID trade resume, and then by December, another outbreak. Now you can see that there is quite a bit of changes in the amino acid, indicating there is a rapid evolution of the CVID virus. Now to me, this is very abnormal. Although other researchers in my department say that, hey, no, CVID is the natural host. I say no. If CVID is the natural reservoir for SARS-CoV-1, it should have gone into evolutionary equilibrium. The mutations should not result in changes in the amino acids. It should be a neutral sort of mutation, what we call synonymous mutation. But we have a lot of non-synonymous mutation. That is abnormal. It shows that the virus in the CVID has just jumped from somewhere else. Another animal have given the CVID a virus. And that's why it's rapidly evoluting, because of the selection by the CVID immune system, for example, or to adapt to the cells in the CVID. And then many researchers show very clearly that in the market there are a lot of CVID having antibody or having virus, whereas in the farm, very few, if any. And in the wild CVID has no virus at all. Now I say, here, this is my eureka moment. I say that we must find the ultimate natural reservoir. But some of members of the department disagree. So we actually separate. I built another research team to find the natural reservoir. And that is finally found 2 years later in a Chinese horseshoe bat. This is called Rhinolopus sinicus, very small, interesting flying mammal. And 39% of them are carrying a bat SARS coronavirus quite closely related to the CVID and human virus. And then another 2 years later, in 2007, I'd write a review in Clinical Microbiology Review. And in the last paragraph, I say, should we be ready for the reemergence of SARS? And I say this, the presence of a large reservoir of SARS-CoV-like viruses in horseshoe bats, together with the culture of eating exotic mammals in southern China, is a time bomb. The possibility of the reemergence of SARS and other novel viruses from animals or laboratories, and therefore the need for preparedness should not be ignored. Now I say this 12 years ahead of COVID-19. I have to wait there because I'm sure it will come back. I write this, and people say that you are foolish, SARS is gone after killing all the CVID, and there's no more. I just want to say that science, the most important aspect of science, is the ability to predict. If your work cannot predict anything, cannot make anything useful to prevent something from happening, science is not that useful after all. It's interesting, but it's not useful. But if your science is able to predict, that makes a big difference. And since 2007, I'm actually begging for money from the government to do virus surveillance program. And then after so many years, I've discovered more than 18 novel viruses, of which 30 are novel coronaviruses. You can see that I do it in human, bat, birds, cat, dogs, etc., even buffalo, sea lion, camel, hedgehog, etc. And I then received some complaint from the funding agency. I don't want to say which funding agency. He said, KY, you're finding a lot of viruses in animals with no public health significance. I'm very afraid. That is, I think, in 2012. I'm very afraid because they will cut my funding. They will stop the funding. Now, I was so lucky because one morning when I read the New England Journal of Medicine, they isolated novel coronavirus from a man in Saudi Arabia. And finally, it's called Middle East Respiratory Syndrome coronavirus. And here it says in the summary the closest known relatives of this MERS coronavirus are the bad coronavirus HKU4 and 5 that I discover. So I say salvation comes at my desperate time. I immediately send the paper to the funding agency that what I did is so important. It's published in New England Journal of Medicine. Don't say that the money is wasted. And also, you know that Hong Kong U have a hospital in Hong Kong U Shenzhen Hospital. And at that time when it was founded, many clinical staff refused to go there to work because of various reasons, insurance, medical legal reasons, and we are all working our guts out already. Why you still make us go to work there? Every morning I have to wake up at 5:30, then get into the van at around 7 o'clock, and then start working there at around 8:30, and then come back in the afternoon around 5, and then start my work in Queen Mary Hospital. That is very hard work, I must say. And I become the chief of service of microbiology there, and also infection control. But actually, that is very important. After 8 years of work there, in 2020 January, a family with 6 people, 5 getting down with COVID-19, came to our hospital. And we are the first group in the world demonstrating person-to-person transmission of SARS-CoV-2, COVID-19 outbreaks in a family. This family is a Shenzhen family who fly to Wuhan. They visited hospital, visited the relatives, and then come back to Shenzhen, and then come to our hospital. And of course, we found the virus, the SARS-CoV-2, on the 10th of January 2020. Although we are not the first, but we are already the first to show its human-to-human transmission and completely change the control policy, the infection control policy of SARS-CoV-2 COVID-19 control. Now, and then in 2021, which is another 2 years later, there is 3 Haitian children. They suffer from a porcine Delta coronavirus that again found by us in 2012 in Hong Kong. And I'm happy that they published in Nature, but we actually found the virus 9 years earlier. All right, so prediction is very important. I just have to end here because I'm over time already. That our Hong Kong U paper published in Lancet on person-to-person transmission of SARS-CoV-2 was chosen by Lancet as one of the 34 landmark papers in their journal 200 years of anniversary, along the paper of discovery of penicillin, and also along the paper about antiseptic technique by Joseph Lister, which makes surgical operations safe. Thank you very much for your kind attention. Thank you.